Hello everyone. Today there is a little bit serious theme for this video because a crash happened with the SUX vertical, and in this video I want to figure out why this happened, and I want to do this with you. So after this video maybe you got an idea or an opinion what could be the reason for this crash, so please write it down in a comment. This really would help me to understand this completely. I want to show you what happened. We want to talk about what could it be, what could it not be, and how to prevent this for the next time. Because one thing I can tell you, this jet will be rebuilt, not repaired. It will be completely rebuilt with a lot of new things and new constructions, and this should be get up in the air again. But for this moment we want to talk about this jet, and let's start with the footage of the crash for you to see what happened. All this happened while I did a normal vertical takeoff till about 10-meter altitude, when it was the left wing, when the left wing suddenly goes down, and with a slowly rotation, and till the jet was upside down. And then, because of the thrust of all these EDFs that normally should get up the plane vertical, now they press the jet down vertical, and it crashes hardly on its backside. This we can see here one time from the onboard cam, and also filmed from outside. So let's first take a look at this, that you see everything, and then we want to go step by step, take a closer look to what we see and think over it, if this was an influence or maybe the reason for this crash. So let's start. So first we want to take a look if it could be a disruption or interruption of the transmitter signal, and I don't think so. I did all the pre-flight checks, also the range check, and everything runs absolutely normal. And the good thing is the onboard cam. We can see that when the wing starts going down, the left one, or so the plane starts rolling, I give full left aileron, and this you can see in the video. First I give it and then I take it back. I saw no reaction, and then I give it again and hold it on maximum till the plane is down. And I think this shows that there was a connection between my transmitter and the plane. This aileron couldn't move by the gyro, because the gyro doesn't do these maximum moves, and it couldn't be the gyro that moved the aileron, because the gyro is working in the normal gain mode, not in a heading mode. And so when there is a movement of the plane, he just reacts for some seconds, and then he would take the deflection surface back. But we saw that the deflection surface is held to maximum, because I want to stop this rolling maneuver all the time till it wasn't possible. And so I think the transmitter was okay. There was no disruption, and this couldn't be the reason for the crash. Next idea, maybe it was caused by the battery, by the flight battery. I also don't think so, because the battery is absolutely new, yeah? And I did a lot of flights and hoverings. This battery works absolutely fine. I have a telemetry control on my transmitter, so I can see that the battery holds its power till the end. So the battery works absolutely fine, and it was fully charged, and these were the first flight seconds. So the battery was okay, and I don't think that it has something to do with the flight battery. Was it a malfunction of the KK copter board? I also don't think so, because this behavior that one wing gets down haven't happened never before, never ever. And this jet is in service since 2017, like you could see in a video before. And it has hours of hovering time, and I think maybe hundreds of transitions up there. And I never saw this behavior. What I saw, that the plane starts shaking. But this was caused of not optimum setting, this fine setting of these gain and stabilization settings, which have to be done manually. Yeah, and this is quite normal. This is why I did a lot of test flights and a lot of test hover. But that just the wing goes down and there is no reaction from this board, because all this board want to do is hold this jet in level. This is the reason why this board is installed. Yeah? This is my little brain on board the SUX that level the jet on a lateral, horizontal and vertical axis and hold it stable. Yeah? So, and the next point was one of these lift fans defect. I checked them in front of this flight. Like I told again, I did a lot of hovering time and also a lot of flights and also vertical takeoff with direct transition, just minutes before, and there was no problem. And also this still work. Yeah, I did check them after this crash, and they work. So this wouldn't be also the reason for this crash. So the question is, what was it then? And now we came over to a specialty of this little model airport. And I want to explain this here. Here we have this is our little airport, and here is a little road, and these are trees. Yeah, these are trees. They are also about 10 meters high. And one problem that appeared is when we have wind from this side. Here is north. Yeah. Here is the north side. Yeah. So here is west, east, and south. And when we got wind from this side, turbulences appear on these trees. The trees are also on the other side of the street. So this is like a wall. This is like a 10-meter wall for the wind. And when the wind came from north, here we have these turbulences. And last year I had a crash with the SUXR, and this crash was without flying anyway. This crash appears just by doing my transmitter range test, and for this test I drive circle, and there was this north wind. It was about 15 kilometers per hour, and this wind let flip my jet over on the ground. Yeah? Some vortex must be created because of these trees, and these vortex are strong enough to let a 6.5 kilogram jet flip over on the ground. Yeah? So I knew that there was this problem with this wind and with this vortex. So I carefully checked the wind conditions before I get to fly anyway on this little airport with the weather forecast, and also I check it when I'm there. I grab some grass and let it fall down, that I see how much wind and where does the wind came from. And at this time it was 8 o'clock p.m. So late afternoon. It was nearly no wind, and a little wind, there's my pen, came from northeast, about this. Yeah, very little. Let's say constantly 3 kilometers, but from time to time it freshes a little bit up, maybe to 5 kilometers, really not much, but you feel there was a little wind. Yeah, it came up. And we also can see this from the onboard cam. We see these windmills. Here we have these windmills are standing about there. We can see their direction. Their direction is that they look to the north. So in higher altitude, there seems to be exactly this north wind. Yeah? Where on the ground, with my grass check, I saw the wind was about 45 degrees from northeast, but higher in level there was this north wind, and it seems to be a little bit stronger than I saw it on the ground. And my idea for this crash, what happened, that the jet get into one of these vortex, and these steering fans, these leveling fans, were not strong enough to hold the jet in level. Yeah? What is speaking pro this theory is that it was going on very softly, but it didn't stop. But the other hand, what is a little bit talking against this theory is that I can't hear clearly a change of the sound from the fans. Yeah? You have the onboard camera and we can hear sound. And normally when one wing gets down, this fan from this wing powers up till its maximum, and this gets very loud and we should hear it. Yeah? I wanna show this now. Yeah? I wanna bring some power to this jet, and we will hear what happened when a wing gets down. So here we got the main body of the SUX vertical. Yeah, so far so good. This is put into this jig. This is normally used for painting this jet, and I can roll it along the longitude axis. And what we want to check now is what happened when I put these 300 gram of weight on some wing. This weight simulates the wind from the wind gust or the vortex that I think over that grabs the jet, and we want to see what happened, and we also want to hear what happened. So I start the engines and then I put on this cup with this weight. The jet is leveling and I put this on, and you hear the sound. This engine gets up and it's leveling again. Okay, this is working. Yeah, we see everything is working fine, and the next thing is maybe the wind itself does something on the airstream of this small fan, on the aerodynamic of this fan. So I got here this wind machine with also 90mm EDFs. And this is now blowing to this wind, and we want to see what happened there. So now I want to simulate the same, not this time not with a weight, this time with wind. Yeah, from this EDFs, wind is blown to this wing, and let's see what happened. Okay, we saw that the wing goes down, but it doesn't go down so much like we saw in the crash video, and it get nevertheless turn 180 degree around, that the plane is upside down. So I think this vortex must be very strong, yeah, to flip it over, or yeah, really don't know what happened up there. But these were the first tests, and yeah. So, and what I want to do in the following is to change this 70mm EDF with about 450 watt and nearly 1 kilo of thrust to this 90mm EDF. This is a customized Wemotec MIDI fan. And this is much stronger. Yeah, this is in the test at the moment, and these ones also give the whole jet more power while leveling and make it more economic. So the next SUX vertical will be built with these jets, and they are much stronger and can hold the whole jet and level much better even in windy conditions. Yeah, that for this video. I hope you enjoyed it, and see you in the next one. Bye bye.